Hi, in the last session, we talked about 12 connectivity and we seen that how it can improve the user throughput and how it can improve the user experience for better throughput to fast load balancing and improved mobility robustness. Now, in this session, we will explore the concept of flexible numerology in 5G. We will understand that why it is important and we will see that how it works within the network. Let's begin by looking at the LTE frame structure, and then we will compare it with the 5G NR frame structure to understand the differences and improvements. Similar to LTE, the NR frame in 5G is also 10 millisecond long. So this frame length is common for both the technologies. Today, LTE supports carrier bandwidth of up to 20 MHz and it uses a fixed OFDM numerology with consistent parameters across the network. LTE employs a 15 kHz spacing between OFDM subcarriers, and this is standard across the whole LTE network. LTE frames are divided into two slots. Each slot has zero point 0.5 millisecond, and each slot contains 6 or 7 OFDM symbols. So in LTE, the symbol duration is approximately 66 microseconds, which is same across the all LTE deployments. Now, when designing a new air interface like 5G, it's important to carefully select an appropriate symbol duration to optimize the performance. But before that, let's understand two important concepts that affect symbol duration. These concepts are delay spread and coherence time. Both of them are important concepts in wireless communications. Delay spread refers to the time difference between when the first and last significant signal reflections arrives at the receiver due to multipath propagation. So if you send an impulse in the air, then there is a concept called multipath effect. So when this impulse is transmitted, it takes various paths and reflections to reach at the receiver. And because they are reflecting from different surfaces and follow different paths, this one signal impulse reaches at the receiver in multiple pulses. And because of different paths, they arrive at the receiver with slightly different times. This variation in the arrival times is named as delay spread, which is a key factor in wireless communication. Larger cells usually experience higher delay spreads. So, the delay spread is the gap of duration between the first receiving impulse and last receiving pulse. Now, let's discuss coherence time. So, coherence time refers to the time period during which the characteristics of a communication channel remains relatively constant. It is the duration over which the channel response is stable, means it does not change significantly. Higher frequency bands and faster moving user equipments or UEs typically results in shorter coherence time due to rapid change in the channel conditions. Now the concept is to ensure the reliable communication, the symbol duration should be shorter than the coherence time and significantly longer than the delay spread. And from the 5G spectrum, we've seen that a 5G supports multiple frequency bands, including multimeter bands. Now, 5G is expected to support a wide range of frequency bands and various cell sizes and fast moving user equipment. Now, because of this diversity, a single symbol duration is insufficient to meet all these needs of different scenarios. So, we are needing additional flexibility to select the symbol duration. And to address this, 5G NR introduces flexible numerology. Now that allows various symbol durations to match the different use cases and network conditions. Like LTE, 5G NR also have a 10 millisecond frame structure, but now it has added more flexibility in the subcarrier spacing. Means unlike LTE, 5G NR supports a range of subcarrier spacing that is from 15 kHz to 240 kHz. So that provides more adaptability for the different scenarios. Although this picture here only shows up to 120 kHz, but please remember that NR can support up to 240 kHz subcarrier spacing for even more flexibility. Each NR subframe is still limited to 14 OFDM symbols, just like we have LTE, but 5G can adjust the subcarrier spacing. So the number of symbols per frame is fixed at 14, but the duration of each slot decreases as the subcarrier spacing increases. So it allows faster data transmission. And hence, larger subcarrier spacing helps in reducing latency as well. because it allows data to be transmitted in a shorter slot durations, which is crucial for time-sensitive applications. This kind of flexibility brings the better configuration for different type of deployments according to their most suitable properties. For example, outdoor macrocells operating on the lower frequency bands like 700 MHz can use 15 kHz subcarrier spacing, which is better suited for the environments with high multipath interference. Mid-sized indoor deployments can use 30 kHz or 60 kHz subcarrier spacing due to their smaller cell size and the need of efficient spectrum uses. Although millimeter wave deployments, which offers extremely high bandwidths, they require careful selection of subcarrier spacing. So if you use a smaller subcarrier spacing in these high frequency band, then the FFT computation or fast Fourier transform computations can be more complex and challenging. In addition, they also have smaller cell sizes, so a higher subcarrier spacing suits them better. Okay, so that's it for today. I believe now you have some basic understanding on 5G NR, flexible numerology, and how to use it in network for better performance and for better user experience. This was also one of the major update in 5G NR network compared to the legacy 4G ALT network. In the next session, we will be talking about mini slots, preemptive scheduling, and self-contained slots in 5G. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.